discrete area graph and dual combination graph. Okay, so let's look at all three of them. It's very similar to the line graphs, except you have to understand in what way the line graph is different from area graph. So sales, product category, so same three. So we have the order date, so time will be the x-axis, then you have sales on the y-axis, and we have the three categories of the product categories, okay, furniture, technology, and office supplies. So see what happens now when you do a continuous area graph. Okay, so you have the first category, the value, whatever that value is, and then added to that the second category, and you add to that the third category. It is something like a cumulative graph. See, when it is a line graph, each line, the height at which the line is plotted, that would represent just what the value for that category is. Okay. So now what you're doing is you're doing accumulation. Yeah. So if comparison is what you're after, you're wanting to compare one category with another category, then line graph is better because the comparison is immediate. Okay. But if you want to, if comparison is what you're after, then this is not very good. The area graph is not very good because it's hard to compare. How do you compare that with that? Sometimes it's hard, sometimes it's maybe easy. But if you have a line graph, then you can immediately see the comparative values. Okay. So now again, this is green pill, so that means it is continuous. So when you drill down, you get the same kind of effect like in the continuous line graph, except that here the areas are cumulative. Okay, if you plot one on top of the other. Okay. Now same thing for discrete area graph, and again if we do the same three variables and you take the discrete option. Okay, so again it looks the same, except that now it is no longer continuous. So every time you drill down, it's going to take that one particular bucket and then slice it up into smaller buckets. Okay. So now you have smaller buckets like that. So it's not continuous. Okay. So the difference is the cumulative. The difference between area and line graph is the area is cumulative. Okay. Now finally, in this set of three, we have the combination graph. So we're going to look at one more. Okay. So now to do this graph, the dual graph, which includes shipping delay or lead time to ship. We don't have a lead time calculated here, right? So we have to create a new measure, so calculated field. So you have to create a calculated field, okay, and we will call this time to ship, right? Now we have two dates here, order date and ship date, and we want to find the difference. But then these are dates. How do you find the difference between the dates? And Tableau offers a bunch of date-related functions. Okay, so here are the date-related functions. Okay, you can, and date diff. So that's going to give us the difference between two dates. So here is date 1 and then date 2. Okay, So the first date and the second date, the earlier date and the later date. Okay. Now start of week can be Sunday or Monday or Tuesday or whatever, but that's optional. You don't have to, you'll assume, I think Sunday would be the start of the week. I'm not sure about that. Now the date part is when you find the difference, how do you want that difference to be expressed? You want that as number of years, number of months, number of quarters, number of days, number of weeks, what? Okay. So the options for the date part of this, date part can be any one of these. Okay. And the difference will be converted to that time unit. Okay. So here we want the lead time to ship in days, so we will use day as our date part. Okay. So that is going to be date diff. Okay, so now Tableau prompts you with that function, and it also tells you what we need to enter here. So the first one is day, so that's the time unit in which you want the difference to be calculated. Right. The start date, okay, chronologically the date that comes first, so which is the order date for us. All right. And then the end date is ship date. Okay. And we don't really need the start of the week here. It doesn't matter what the start of the week is. And the calculation is valid. You have to check that, make sure that you've entered things correctly. Okay? Click OK. Okay, so now we have time to ship showing up as the measure. So now you select that, then you select sales and order date. So these are the three fields that you have to select. Okay, and then select that one. So that's your dual combination chart. Okay, so now we have the sales for each year and then time to ship. Okay, there is only one problem here. What do we want the time to ship be? So these are time to ship calculated for each order, right? Okay. So now how would you want that time to ship be plotted in this plot? So you do want how much did we sell in each of these time units, okay? And you want that to be the vertical bar here. That's good. Now here the time to ship, okay, what is the default, what is it, the aggregation that it is doing? It's summing the time to ship. Okay. Now, does that make sense? So if you have more orders, then you'll have more, you're just summing all those differences. So for this particular measure, it would make more sense to see on the average how long are we taking to process the order and get it out of the door, rather than simply sum of the shipping days. So it makes more sense to change this to an average. So now we have average shipping date. So as you see, the longer we take, looks like the total sales is falling down. Okay, and of course you can, since this is a continuous, okay, green pill is continuous time, so you have a continuous graph there. You can, you can see where exactly and in which time period the lead time to ship is increasing or stays the same or what. So here you have particular problem. Okay, it's what happened in November. So why is it so high compared to the rest of the time periods?